Okay, this is the lecture for section 8.3. I actually have the theorems for 8.3 and 8.4 all on one handout, so I'll just discuss the section 8.3 theorems right now and do the problems associated with that section, and then I'll do 8.4 theorems and problems in the next video. So in section 8.2, you were learning how to solve triangles, in other words, how to find any missing side or any missing angles by using the law of sines. And we talked about cases that were ambiguous. We talked about cases that were not ambiguous. And we looked at a lot of different examples for using that particular law. So now I want to point out that when you were in section 8.2, and I do have a summary that I've prepared for you where I compare both sections, that the reason we were able to do law of sines is because in the triangle we were given a side and an angle across from it, as well as one other piece of additional information. And that enabled us to do law of sines. Specifically, these are the cases. Just since I'm talking about that, I'll skip over to this summary right here. So in section 8.2, the section that we just finished up, if we had two angles and a non-included side, in other words, a side that's not in between the two angles they've given you, or if we had two angles and a side that was included between each of the angles, that allowed us to do law of sines. We also could do law of sines if we had two sides rather than two angles. These are both cases where you have two angles and either a side that's in between, like this, or not. But we can also do it in a case where we have just two sides and only one angle. But when you only have one angle, you are in what's called the ambiguous case. And that's only if the angle is not in between the sides. Notice that the A is on the outside. That means you have two sides and then an angle that's not in between them. So in this side-side angle case, we call it the ambiguous case. And you can come up with one of three solutions in that case. You either have a triangle that doesn't exist at all, or you might, and that's called the zero solution case, or you might have a triangle that has only one set of solutions. That's called the one solution case. Or you might have a case where the picture and the values you've been given based on side-side angle actually split into two separate triangles, and that's called the two-solution case. Then we now come to 8.3, and instead of being given two angles and a non-included side, or two angles and an included side, or even this case right here, we are given none of these things. Instead, in this case, and this is when you have either side angle side or just three sides, this is when you're going to be forced into using the law of cosines. Because remember, once again, if you're going to use law of sines, you must have a complete pair. In other words, a side and an angle right across from it, as well as one other piece of information. Whether that third piece of information be a side or an angle, irrelevant, but you have to have that complete pair. And in these two cases, you don't have that, and so you're forced into law of cosines. Okay, that brings me to the law of cosines, and I'll point this out to you in picture form, how you know, once again, whether or not you should do law of sines or law of cosines. One thing I did want to remind you is that, and this is something to be aware of as you look for your answers, so that you make sure you're not giving a set of answers that don't make sense. First of all, for any triangle to actually exist, in other words, for the sides to come together at each of the vertices, it must be true that the sum of the lengths of any two sides, you could add up any two sides, and that sum should be bigger than the third remaining side. That is not true here, which is why this triangle doesn't close up. That's called the triangle inequality theorem. Sometimes it's called the triangle side restriction. So when you add up those two sides, you see how the sum is 7, but that sum needs to be greater than the third remaining side, and it is not. So therefore, the triangle can be formed. No triangle is formed here. Now, as I stated on the page that I just flipped to where I showed you a summary of section 8.2 and 8.3. I was saying that in two particular cases, you will be forced into using the law of cosines because you just won't have what you need to start the problem with law of sines. And that will be in the side angle side case. You'll be forced to start the problem with law of cosines. Side angle side, or if I just give you three sides. Both of these will force you to start with law of cosines. You will then see that after you begin the problem by using law of cosines, that you will finish the problem using law of sines, which is actually, less work than law of cosines. So of course, if you can finish the problem in that manner, you should do so. And so you'll see me doing that. I may have to start it with law of cosines, but it doesn't mean I'm going to be using law of cosines the whole way through. Okay, so in order to memorize these theorems in a somewhat easy fashion, notice that they all start off with something that kind of looks like the Pythagorean theorem. So whatever side you start with right here, that side has to be across from that angle. Notice that if this starts with A, side A, remember we use lowercase letters for sides, then it finishes with angle A. If it starts with B, it finishes with angle B. If it starts with C, it finishes with angle C. Contents in the middle, this would be the other two sides. So if you have A squared here to begin it with, then the other two sides are called B and C. Every single one of them squared. If you start with B, then the other remaining sides are called A and C because we have always, traditionally labeled the sides A, B, and C. So if B is here, then A and C is what remains. Everything in its squared form, likewise here. If this is C, A and B remain. So those will be the first two items on the right side with pluses in between them. And after you've mentioned those two remaining sides, that will be followed by a minus in each case, and then a product. And that product will start with a 2 in each case. So it'll be minus 2, minus 2, minus 2. And the product that you're seeing right here are these sides that are on the same side that you're on right now. All of this is on the right-hand side. So if B squared and C squared were mentioned here, this product will be B times C in its linear form, rather than using the second degrees. If A and C were mentioned here, then A and C will be in this product. A and B, A times B. And then since this is the law of cosines, that last thing in this back product, because this is all one product, is cosine of A. Remember, this will be the angle across from this side as a way to help you memorize it. And all of them finish off with the cosine of some angle, that angle being the angle across from that side. So hopefully that can help you to memorize all three at one time and to even be able to do it when there aren't letters on the sides. Okay, so now let's go into the problems associated with this. On the last page of this theorem outline that I'm on right now, you'll just see the two theorems that are used in the last section, which are 8.4, but we won't go into that yet. Okay, so let's take a look at the problems that you're going to be doing from MyLab Math. And here is the first one. And it says if three sides are given, that is something that I just mentioned when I told you when you're going to be using law of cosines. And that's all that question's about. If one side and two angles are given. If one side and two angles are given, just like that. And you can see what I gave you right here. If one side, let's see, if one side and two angles, and you can be given it like this. One side and two angles, but you could also, instead of the side being not in between the two angles, you could also have two angles and a side like that. So in both of those cases, whether you are given the two angles, but with the side included, both of these are law of sines. This was from section 8.2. We were doing all of the law of sines. Okay, again, you are only using this law of cosines for side, 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 or side, angle, side. And that'll become even more evident to you as you actually do the problems rather than recite, hey, in what case do I use this and in what case do I use that? Okay, but you can use the summary sheet, the theorem sheet that I gave you to answer questions like this. Okay, this says if two sides and an included angle, two sides and an included angle, which law can be used? I already stated that up here. Two sides and an included angle, that would be the law of cosines. Okay, decide whether the following statement is true. Given only three sides of a triangle, there is insufficient information to solve the triangle. That is false. When you have three sides, you can use law of cosines. Again, as I stated in problem number 1. Those are the two cases where you can start off the problem using law of cosines. Okay, going to number 5. Decide whether the following statement is true or false. A special case of law of cosines is the Pythagorean theorem. And yes, that is actually true. And you know you have all the answers for this on the back pages. Yeah, I know I included all of them for you guys. Okay, let's go to where we're actually doing the problems. I'm more concerned with you being able to do that. Okay, so round to 2 decimal places. Notice that we have 3 sides here. And no, what do we have here? Actually, we don't have 3 sides. We have 2 sides and an included angle. So this is one of the cases, side, angle, side, where you're going to be starting the problem off with law of cosines. Okay, so we have side, angle, side, side, angle, side. So now we're going to start off with law of cosines. Notice that the only angle that you have is angle B. Angle B has to be acquired from side B. That's how you know this is called angle B, besides they label the other ones A and C. So you're going to be using the law of cosines that has angle B in it and therefore starts with side B. So you're going to be using this right here. You're going to use this formula, that B squared, then these would be the other 2 sides, the A and the C. And of course, this is A, and across from C, this one's called C, minus 2 product of these two in their linear form times cosine of angle B. That's what you're going to be using to do this problem. So start putting the numbers in there that you've been given, and you'll solve for the thing that you don't have. So this will be side B, unknown. We don't have anything to put in there, but we do have an A. Formula says square it. We do have a C. Formula says square that, and we're going to do minus 2 times A times C. The A again being the 7, and the C being the 8. And then we also have angle B. So there's only one thing, and you should only have one thing unknown when you start the problem, or else you have picked the wrong formula out of the 3. So now you're going to put all that in your calculator. Let's see if I can shine the light on here. Make it a little bit more visible. Okay, so let's see. We have 7 squared plus 8 squared, and you can actually put it in its squared form. I'm just doing it myself. Minus 2 times 7 times 8 times cosine of 40 degrees. Let's make sure the mode's in degrees. It is, because otherwise that'll make it come out wrong. Okay, so that you have side B, and it says that we're going to round to 1 or 2 decimal places, so that would be 27.20. Whoops. Actually, I'm not ready to give the answer because all I got so far was for that. So all I did was get the number that is on the right-hand side. I'm kind of jumping the gun. So I'm kind of still in the middle of the problem. It's 2030, and when I'm in the middle of the problem, I hold on to 4 or 5 digits. In the final answer, I will actually round to 2 decimal places. So I just put all of this in the calculator. I got 27.20302. And on the left side of the equation, I have a b squared. And so if I want to go from b squared to b, then you know the deal with that. You take the square root of both sides. And now I'm going to approximate to 2 decimal places. So now it's second, square root, dump in the answer by just typing in second, enter, or second, the minus sign next to the enter, which is down here. And then the final answer is to 2 decimal places, 5.22. Okay, so that's one answer. And you can dump these onto the picture as you go along. So 5.22. And then the next thing that I'm going to do is I was telling you that when you do these problems, you should start with the law of cosines when the problem mandates that. Because remember, you are going to take a test where they're going to be mixed up. So the reason, let me go over this. The reason that I couldn't start with law of sines was because the one angle that I did have, I did not have the side across from it. Not to begin with anyway. That forced me into using law of cosines because I didn't have that one, at least one complete pair where I had an angle and a side. So I had to start with law of cosines, and now I'm going to finish the problem by switching to law of sines. And I'm going to finish this on another piece of paper. Because I'm going to run out of room. Okay, so we had B here. We had side C is equal to 8. This was angle C. This was angle A. We had A is equal to 7. And we just found out that B is approximately 5.22, so we'll use it just like that. Okay, so the angle that we did have was 40. So you see that now, once I found that 5.22, I actually do have a complete pair right here. I have an angle and a side across from it, and that's what enables me to continue the problem without such a long theorem or such a long equation such as law of cosines. I can just do it with a simple proportion. So let's see, I'm going to use this pair, and then it's up to you what you go and find after that, but I'm going to find, let's see, I'm going to find the smaller one. So I would go after A, the smaller angle, and I know this is the smaller angle because of the 2 sides that are left. This is smaller than that. Smaller angle is always across from the smaller side. So I'll leave the biggest one for last. All right, so here we go in this situation, and I'm going to be looking for an angle, so I'm going to put angles at the top. So I'm going to go sine of angle A, which is across from a side called 7, and then I'm going to do one other pair, which is sine of 40 across from 5.22. So I got my law of sines. I'm going after angle A, which is the smaller of the 2 remaining angles. Okay, now I want to isolate the thing that's unknown, which is sine of angle A. Remember to put your unknowns on the top because this will decrease the number of steps you have by 1. We're going to swing this 7 right up here, So it's no longer there. And we have sine of angle A. Put all this in your calculator. So it's sine of 40 degrees times 7 divided by 5.22. And you get 0.86198. And then don't forget, if you're looking for an angle, that has to do with inverses. So it's inverse of 0.86198, and that'll be equal to our angle. It says for the angles to round to 1 decimal place. Let's go ahead and put that in the calculator. So this is going to be second inverse sine. And then I'm just going to dump this right in here by going second answer, which is the little minus next to the enter key. And that gives me, to 1 decimal place, 59.5. I'm on my way to completely solving this equation. Okay, and then this next answer where I'm going to find, let's put here that this is angle A. Because when you switch this, you know it's inverse sine of this is equal to angle A. That's what I was doing when I went into this step. Inverse sine of angle A. Inverse sine of 0.86198 is equal to A. Okay, that's what that was about. So now for this third one, we can go angle C. It's just 180. Take off the 2 angles that you have right here. And you can either add these together and just subtract one time, or you can subtract them one at a time. That's up to you. So I'm just going to put it like this, that I'm subtracting this angle as well as this, and then you can just pop that into the calculator. And that would be 80.5. Another thing that you should check when you go to finish this problem, this should always be true. This has a mini check on your answers, that the smallest side should be across from the smallest angle, the medium side should be across from the medium angle, and the largest side should be across from the largest angle. Make sure that that's true. Okay, largest angle here is 80.5, and it is indeed across from the largest of these 3 sides. Medium angle is the 59.5, and it is across from the medium-sized side, which is the 7. It's in between, this is the largest. And then smallest angle is across from the smallest side. Okay, so we are finished with that. We have all 3 angles, all 3 sides. Moving on to number 2. Problem number 2. I think I'm just going to do the whole problem right here because I know I'm going to run out of room if I do it on the other paper. So in problem number 2, they give you this triangle. There's a B here, even though they put them inside the triangle. I like to put them on the outside. This is A, B, and C. And then this would be side A that they give you, coming in at 6, and side B they give you, which is 3, and they also give you side C, which is 4. Okay, so for 3 sides, I'm going to find the smallest one first, then I'll find the next biggest one, then I'll find the next biggest one. I'm just going to go in that order. And so, if I'm going to find the smallest angle, then that means I'm going to be working with this side right here. This is the smallest side, therefore B is the smallest angle. So I'm going to start off with this. B squared is equal to A squared plus C squared. I know that if I'm looking for this angle, which is called angle B, then I should be starting with side B in the formula that I'm choosing. Minus 2 times A times C, but in their linear form, times cosine of angle that's across from this, B. So then it is 3 squared is equal to the other two sides squared, which are 6 squared and 4 squared, minus 2 times A times C. That A value is 6 and 4. Those are just the values that are on the side we're working on anyway. And then cosine of just one thing being unknown, and that is an angle. You will have to inverse in order to get that angle. Okay, so this would be 9. I'm going to do a little bit of work here. This would be 36. This would be 16. And then this would be 2 times 6 is 12. And then 12 times 4 would be 48. You can get your calculator to help you with all of this stuff. Be careful with this stuff, because I see a lot of students that when it's this particular case, they add all those numbers together. And that's a pretty common mistake. You can add these two numbers together, but you may not add a multiplier. This is the multiplier of cosine, and they are bonded together. That 48 can only be removed through division. Okay, but you can add these together, which would be 52. And again, you can get your calculator to assist you with as much or as little of this arithmetic as you want. Okay, so this is what we have so far. We got 36 and 16 added together, we got a 52. We have a negative 48 multiplier in front of the cosine. But before I remove the multiplier of the unknown, you always remove the multiplier of the unknown. Should be your last step, always. Even when you're solving an algebraic equation. Things that are added or subtracted to the unknown, like this, they should be removed first. So if this is a positive 52 and I want it to go away, I subtract 52. And you can just use an arrow to show that if you want to. That goes away. I'm left with negative 48 times cosine of the unknown angle I'm looking for. 9 take away 52. Negative 43. Okay, now it's time to get rid of that multiplier of negative 48. So divide both sides by negative 48. That'll leave you with cosine of the unknown angle by itself and give you a decimal for the left-hand side. So we already have the negative 43 in there, divided by negative 48. That gives you 0.89583. Okay, don't forget that when you're looking for any kind of an angle, that involves inverses. And to go from a non-inverse statement, a direct statement, into an inverse statement, all you ever do, all the way from chapter 6 and 7, is switch these two. But mainly that was in chapter 7. You just go cosine, and where this b is, the decimal will now be. And then the b will jump over in place of the decimal. That says angle b is going to happen through inverse. We went from a non-inverse statement to an inverse statement. And you do that just by switching those two things. Pop that in your calculator. So now it's going to be second inverse. Dump that in there by typing second answer. And you have 26.4 degrees. And in this problem, it also says to round to one decimal place on those angles. Okay, so 26.4. Okay, now I'm going to find, let's see, I'll find the next biggest one. So this was the smallest angle. Now I'm going to go after this one. I'm going to go after angle C. All right, so let's see, I can squeeze that right in here. And notice that at this point, in this picture, which I'm just allowing you to see now, in this picture you now have a complete pair. You have this pair and this side. And the minute that you have that going on and at least one other piece of information, which you have more than another piece of information, you're ready to jump into law of sines. So all of this was how I started the problem with law of cosines because I was forced to do so. And now I'm going to move into law of sines. Okay, so law of sines, I could use this complete pair. I am looking for angles, so I'll put angles on the top. So let's see, I'm going after angle C, so I'll go sine of angle C over side C. Then I'll do one other fraction, my complete pair, and that'll be sine of the 26.4 that I just found, and that's across from 3. I want to isolate the one unknown that I have, which means I have to swing the 4 right up here. So I'll just cross multiplying there. That won't be there anymore, and you will just have sine of angle C equal to whatever this decimal is that you get in the calculator. So let's go ahead and go sine of 26.4 times 4 at the top divided by 3. And that gives you approximately 0.59285. And then if you want to get an angle out of that, you have to turn this into an inverse. So inverse of the decimal gives you the actual angle. Okay, so C is approximately, we're going to round this off, put it in the calculator. It's inverse sine, dump in the answer, and we get approximately 36.4. Okay, so there's another answer. We have this one to begin with. So we started off with law of cosines. And we started the problem. And then the second thing we did, so this was the first thing I did, this was the second thing I did. Okay, now we can go to something. You're going to see that all the problems are going to involve into this, unless they are more complicated just by virtue of the fact that perhaps you're in a situation where it's the ambiguous case. Then you have two triangles. So basically, in these problems that are just one solution, you're going to find yourself starting with law of cosines, and then you're going to find yourself, the second thing you'll do is go into law of sines, and then to get the third, final answer, you won't have to use either of those. It'll just be subtraction, as you're going to see me do right now. So to finish this problem, I still have one other angle to find. Right now I know that angle C is 36.4, but yet I still have angle A to find. So I can just go 180 minus the two angles that I already know, and that'll give me angle A. So angle A is 180 minus the 26.4 minus, and that's going to be equal to, let me give myself a little bit more room here. That's going to be angle A is equal to 180 minus 26.4 minus the 36.4, and that is 117.2. And that's that third and final answer. Okay, let's move on to number 4. Or no, not number 4. We are doing, let's see, what problems did we just do? I was numbering these 1 and 2, but this was actually number 6. Which I started on the paper. This was number 6, which I started on your handout, but then I moved over to here. And this was actually number 7. Okay, so we are on number 8. Okay, problem number 8. They don't give you any picture at all, so now you'll just be drawing your own triangle, but no biggie. They give us A is equal to 10. They give us B is equal to 9. And they give us C is equal to 170. And you can actually draw it any way you want because you don't have the benefit that the author has of knowing what the triangle already looks like. So you don't discover that till the end of the problem. What are the big obtuse angles? Otherwise, you could draw a more accurate picture here. So you can just start off anyway. The only thing you do have to make sure is that angle A is across from A, B is across from B, and so forth. Okay, so if you do label it like this, not that you have to, then A would be here, B would be right here, and C would be right here. And we don't happen to know C in this case. Okay, for number, let me make sure I'm writing correctly. Yeah, C, they gave us angle C, they gave us 170. Okay, now let's continue with the problem. So what you have here again, so you know it's law of sines, because remember law of sines is specifically dedicated to side, 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 if you have 3 sides to start with, or if you have side, angle, side, which you do. You have side, angle, side, side, angle. Okay, so the reason, again, that we cannot start with law of sines is because we don't have a complete pair. You need an angle and the side across from it if you're going to start the problem with law of sines, which I would always suggest doing if they give you that. But since we don't have that, then we have to start with law of cosines. Okay, so law of cosines. Since we do have angle C, then that's what we're going to use because all of the law of cosines, all 3 of those equations require an angle. So that angle, if you are given an angle, dictates which of the 3 you should use. You should use the one with angle C in it. And if you're going to use the one that ends with cosine of angle C, then it should start with side C. These will be the other 2 sides. And then it goes -2, A times B. These 2 sides will be the same 2 sides that are on the side you're working on, finishing off with cosine of the angle that's across from this beginning side. Okay, start plugging in everything you have. We don't have C. We do have A. We do have B. And we do have angle C. Okay, this is going to be 100 plus 81. That's 181. And then all of this after the minus sign is going to be the coefficient of the cosine of 170. So you can put that all in. If you want to stick it all in like this, you can do that too. This would be 20 times 9 is 180 times cosine. I like to clean it up a little bit before I put it in the calculator. Okay, now putting all of this in the calculator, we have 181 minus 180 times cosine of 170, and that is 358.26539 or 540. 26540. Okay, and that's what C squared is, but I actually want C. So I'm going to take the square root of this, take the square root of this, so I can go from C squared to C. So C will be approximately, and since we're finding side C, they want us to round to 2 decimal places, whereas the angles, they want us to round to 1 decimal place. So putting this in the calculator, so second square root, dump in that answer. And it's to 2 decimal places is 18.93. Okay, now that I have a complete pair, an angle and a side across from it, I am going to go into law of sines. Okay, so I did this first, this second. Okay, so I'm definitely going to use that complete pair, and then I'm going to go after the next biggest side, which would be across from the 9 rather than the one across from the A. So I'm going to go after angle B. So I'm going to go sine of angle B, which is across from side B. And then I'm going to go sine of angle C, which is known, which is across from side C, which I just found. I'm going to isolate the one unknown that I have. So in the picture, these are the things that I am using. I'm looking for this. It was across from side that measures 9. And I used the complete pair, sine of 170, which was given, and the 18.93, which is across from it that we just found. Okay, cross multiplying the 9 right up here so that it is no longer here and you've isolated the unknown. Okay, put that in the calculator so that you just get 1 decimal to represent all of this. So that's going to be sine of 170 times 9 divided by 18.93. And you get 0.82559. 0.082. 0.082. And that's 5656. And then you go inverse by just switching this and this. That's always the deal. Whether the trig word's on the left or the right does not matter. You need to switch the angle and the decimal. And that'll be approximately equal to angle B. Okay, so second inverse, dump in the answer, close it, and you get an angle that is 4.7 degrees approximately. And this is angle B. Okay, so at this point you have all 3 sides. You have angle B, and all you need is angle C. So third, you can finish by subtraction, since all you have left to do is find that angle. And you've seen that we do this in all the previous problems. Starting off with law of cosine, switching to law of sines, finishing by subtracting. I only need that one angle. I already know 2 of them, so I can just go 180 minus the 170 that I had, and also minus the 4.7 that I have. Okay, and that'll be equal to 5.3. Make sure that, just as a little mini check on your answer, that the smallest angles across from the smallest side, and it is. This is the smallest angle, that's the smallest side. Make sure that the medium angle is across from the medium side. This is the medium angle, the next biggest angle, and this is the next biggest side. And then across from the largest side is the largest angle. That should be the case always with your finished answers. Okay, last problem I'm going to do on this video, I'll do the rest in the next video, is number 9. Number 9, again, you're put in a situation where you are drawing the triangle. Okay, so I'm just going to draw it this way. I'm going to label it A, B, and C. I'm going to put A across from angle A. I'm going to put B across from angle B. and I'm going to put C across from angle C. So again, we are in a classic situation for the law of cosines. And that is side, side, side. It is 4. Side, angle, side, and side, side, side. Okay, notice that even if you didn't have that memorized, you have no angle across from a side. And unless you have that complete pair, you cannot start it with law of sines. So we're forced into this law of cosines. I'm going to go with finding the smallest angle first. That would have to be angle A because this is the smallest side, therefore this is the smallest angle. So I'm going to go after this one first. Okay, if I'm going to go after angle A, I need to start with side A. So I guess I'll write it out for you first and then start plugging in numbers so you can follow it a little bit better. So it's side A is equal to, here's the other two sides, B and C, minus 2 times the product of B and C, finishing off with cosine of the angle that's across from whatever you started with on the left-hand side, angle A. We have everything except angle A. So A is 16, B is 18, and C is 20. Minus 2 times 18 times 20 times cosine of angle A. So, putting these numbers in the calculator, we have 16 squared, that's 256. And then we have, we'll put everything on the right-hand side in there. We'll go 18 squared plus 20 squared, so you can put the whole thing in without stopping if you want. Minus 2 times 18 times 20 times cosine. Whoops, I even messed it up. Okay, let me start over again. So it's 18 squared plus 20 squared. I went too far. And the only thing you do, because all of this is the coefficient of cosine of A. So the only thing you can do is stop right here. You can go 18 squared plus 20 squared. So those you can put together. But those numbers cannot be put together with this only because of this. I was trying to explain this in a previous problem. This is a multiplier, and these are things that are added to the cosine. So this is going to be added to whatever this term is right here. And the term cosine of A happens to have a coefficient of 2 times 18 times 20. So you can't put all those together. All right, so this number was positive. But then as you multiplied these, one of the numbers was negative. So we can switch this number to a negative because it would be a plus followed by a negative. So that's just a single negative. And we got 720 times the cosine of angle A. Okay, be careful with that. Careful with trying to add a coefficient to numbers that are out here. Now you would, now this is the second one that we've done like this, where they gave you, where the only thing you didn't have was the angle. So that became, you know what I'm doing right now, where you have a coefficient and these two numbers was in that other example as well. So I'm going to bring this over here as a negative 724, so it's not there anymore. So it's 256 minus 724, that's negative 468, is equal to, and then you have this coefficient multiplied by cosine of angle A. So the only way that you can remove a coefficient of anything is to divide it off of there. Whereas this number, the 724 that I got from 18 squared plus 20 squared, that was moved through subtraction. So the two numbers are moved in a different way. Each one's moved in a different way, and thus the reason why they can't be combined, as I almost accidentally did. So this cancels. You're left with cosine of angle A, and then here we're going to get a decimal. The negatives cancel, so you need not bother putting them in the calculator. Just 468 divided by 720, you get 0.65. And then if you want to get angle A, it would just be inverse of the decimal is equal to angle A. So angle A is equal to second inverse cosine, dump in the number, and we get to 1 decimal place on those angles 49.5. Okay, so first thing I did, once again, law of cosines. Second thing I did, law of sines. Let's put this where it is so you can get a visual on what is happening here. In other words, that your situation has now changed, which has been the emphasis of the section. Certain configurations of numbers that they could give you force you to start with law of cosines, and then you can switch over once you have a complete pair, an angle and a side across from that. Okay, next angle that I'm going to go for is the next biggest one, and that's going to be angle B. So right now I would like to know what is angle B. So I'm going to go sine of angle B, which is across from 18. Then my other fraction in my proportion for law of sines will be the complete pair. Sine of the angle I just found, the law of cosines, over the side that's across from it, which is 16. Isolating the unknown, which is sine of angle B, is done by just switching, cross multiplying the 18. So that's not there anymore, and you have sine of angle B. Get that in your calculator, put all that in your calculator. So you have sine of 49.5 times 18, and then divided by 16. That's going to be 0.855 or 6. And then inverse it to find the angle. So angle B is approximately inverse sine of the 0.8546 is approximately 58.8. Okay, so we now have a 58.8 degree angle. We have a 49.5, and then that last one, step 3, as you've seen in many of the other problems thus far, you can find by subtraction. So it's just 180 minus the 49.5 that we already found, and also minus the 58.8 that we already found, and that will give you the last remaining angle, which is angle C. All right, so you're going to have 180 minus 180 minus 49.5 minus 58.8, and that would be 71.7. So angle C, you can write angle C like this or without the little symbol, is 71.7. Okay, and that's it for that problem. We will do the remaining problems in the next video for section 8.3.